2024 Antarctic Ozone Hole, a symbol of global environmental progress. The ozone layer, a protective shield in Earth's stratosphere, has shown signs of continued healing in 2024. Over the Antarctic, the annual ozone hole reached its seventh smallest size since scientists started tracking it after the Montreal Protocol's ratification. This environmental progress, marked by NASA and NOAA's ongoing observations, has been driven by the global reduction in chlorofluorocarbon (CFC) emissions and favorable atmospheric shifts that support ozone movement toward the South Pole. The current state of the ozone layer and its annual cycle. Each year, as winter ends in the southern hemisphere, sunlight triggers chemical reactions that erode the ozone layer over Antarctica. The 2024 ozone depletion season, spanning from September 7th to October 13th, saw a moderate ozone hole, with its size averaging about 20 million square kilometers, 8 million square miles, nearly 3 times the size of the contiguous United States. On September 28th, the ozone hole peaked at 22.4 million square kilometers, 8.5 million square miles. This level of depletion, while still significant, is a clear improvement over the massive ozone holes recorded in the late 20th and early 21st centuries. Dobson units, a measure of ozone health. Ozone levels are measured in Dobson units, DU, a standard metric that represents the thickness of the ozone layer. 1 DU equals a 0.01 millimeter thick layer of pure ozone at standard conditions. During the 2024 peak, the ozone concentration over Antarctica reached a low of 109 DU on October 5th, while historical readings from the late 1970s and early 1980s typically hovered around 225 DU. The continuing gap between these figures highlights the progress achieved but also underscores the remaining journey toward full recovery. Global cooperation and the impact of the Montreal Protocol. The Montreal Protocol, signed in 1987, has been central to this recovery. This landmark agreement united countries to phase out the production and use of CFCs and other ozone-depleting chemicals, which were once widespread in refrigerators, air conditioners, aerosols, and foams. By 2010, these chemicals had been mostly eliminated from production lines, replaced by more environmentally friendly alternatives. While the agreement curbed new emissions, the persistence of CFCs in the atmosphere means that complete breakdown will take several decades, projecting full recovery by 2066 if current trends persist. The effects of atmospheric dynamics on ozone transport. While the Montreal Protocol's success is a major driver, atmospheric dynamics also play a crucial role. In recent years, shifts in wind patterns and atmospheric circulation have helped bring ozone-rich air from northern regions to Antarctica. This additional ozone contributes to a smaller ozone hole, although the seasonal depletion cycle remains a regular occurrence. UV radiation risks and the role of the ozone layer. The ozone layer acts as Earth's natural sunscreen, absorbing the majority of harmful ultraviolet UV radiation from the sun. When the layer thins, more UV radiation reaches Earth's surface, increasing the risks of skin cancer, cataracts, and other health concerns. Ecosystems are also impacted. Crops, aquatic life, and critical species in marine and freshwater systems become vulnerable to heightened UV levels, which can disrupt food chains and agricultural productivity. The gradual closure of the ozone hole, therefore, offers direct benefits for both human health and environmental stability. A path forward, monitoring, and future outlook. NASA and NOAA use advanced satellites such as NASA's Aura satellite and NOAA's Suomi NPP satellite to continuously track ozone levels worldwide. At the South Pole, NOAA scientists release instrumented weather balloons to directly measure ozone concentrations in the atmosphere. These combined systems ensure comprehensive monitoring, revealing seasonal trends, the extent of ozone depletion, and year-to-year improvements. The goal remains clear: to restore the ozone layer to its pre-1979 condition. This vision depends on sustained commitment to the Montreal Protocol and future innovations in atmospheric monitoring. According to NASA scientist Paul Newman, the 2024 Antarctic hole is smaller than ozone holes seen in the early 2000s. The gradual improvement we've seen in the past 2 decades shows that international efforts that curbed ozone-destroying chemicals are working. The long-term outlook and environmental legacy. Looking ahead, scientists expect the ozone layer will continue its slow but steady recovery. While setbacks may occur due to unpredictable atmospheric changes, the overall trend is promising. The gradual reduction in ozone-depleting substances marks a remarkable victory for international cooperation in environmental protection, serving as a model for future climate agreements and actions against other environmental threats. NASA's Ozone Watch offers a real-time window into these developments, providing public access to data on ozone levels and changes in the Antarctic region. For now, the smaller-than-expected 2024 ozone hole serves as a hopeful reminder of what humanity can achieve when nations unite toward a common goal. As Earth's invisible shield recovers, the world can look forward to a future where the ozone layer once again provides full protection from the sun's harmful rays, a legacy of dedication to safeguarding our planet.